So this video is going to be on vertical motion, still using the Suvat equations. We're going to follow the same principles in reading the question, drawing a diagram, and then getting our data table. So here's an example. We've got here a ball which is thrown vertically upwards from a cliff top. Okay, so here's my very badly drawn cliff. I'm going to throw up the ball, it's going to get to its highest point, and then of course it's going to drop down again, as it would do if you've thrown a ball in the air recently as well. Okay, we've got some of the information on the diagram. So it says that a ball is thrown vertically upwards with a speed of 10. Okay, so I've used a single arrow here for the 10. And remember, we want to be using these units ms to the -1 rather than writing m/s for meters per second. If we think about what's happening as the ball's going up, it's got this initial speed, but as it goes higher and higher and higher, it's affected by gravity, so it's actually going to slow right down until it starts accelerating downwards. So an extra bit of information that we can add on to our diagram is that at the very top here, this is where it goes through having a speed of 0. Okay, now this is something new to us as well. Everything we've been doing so far goes in one direction. You can see that this goes up and then down, so it's actually changing direction as we go through. So we've got to decide what we want to call positive. And I think the easiest thing to do is to pick up as positive. So I'm just going to draw that on my diagram just to remind myself that up is positive. I've also put on gravity. Okay, we're going to use in mechanics gravity to be 9.8, and yes, this is different to in physics where you're going to use 9.81. Sorry for that confusion. And remember, for acceleration, we've got a double arrow. Okay, so this is what our sketch should look like. Okay, making sure that with anything that's thrown upwards, you've always got your up path followed almost immediately by your down path. Okay, I want to go to find how long the ball takes to reach its highest point. That's up here, starting from here. Okay, so I'm going to put on my coordinates. I might put A there and B there. So I'm actually stating what points I'm going from and to. And then above my Suvat table, I can say I'm going from A to B. Okay, so from A to B, I've got no idea how high it gets, so I can't put that in at all. So I'm just going to cross through S because I don't want to find it either. My initial speed I know is u, so that's 10. My final speed at B, which is where we're aiming for, is 0. So v is 0. The acceleration, we can see, is going down. So as we picked up as positive, then we've got to use -9.8 for our acceleration. Okay, and then finally time, that's what we're actually asked to find. How long does it take? Okay, so that's what we're looking for. So looking at this, we've got u, v, a and t. We've got to find the right formula from our list over here. Okay, and that one's going to be u, v, a and t all in that one. So v equals u plus at. I tend to put the numbers in first before I rearrange, just because it might mean that some things will cancel out. So we'll try that now. So v is 0, u is 10, and then a is -9.8 t. Okay, so I could add the 9.8 t here to get it to the other side. So I get 9.8 t equals 10. And then to find time, I can just do 10 divided by 9.8, which gives me 1.02 seconds. We're going to do every answer in mechanics to 3 significant figures unless it says otherwise, okay? So that's a really important thing for you. Always 3 significant figures. Okay, so in this question, the second part of the same one, we're asked to calculate the height of the cliff. So we're looking for what happens from when it's released to getting to the bottom there. This is when displacement's really important because S is displacement, which is the change from the start to the finish, not the total distance travelled. So this is going to be perfect for this question. If I mark on what I know again, I know that at the top here it's 0, and I've got my other information of the initial speed and the acceleration there. Okay, so this time I'm going from my starting point, A. I remember last time we called up here B, so I'm going to use C for the bottom of the cliff there. So this time I'm going from A to C. Okay, S Oh, once again, we're just going to say that our upwards direction is positive. Okay, S is what we're trying to find here, so that's what we're going to put our question mark on. U we said was 10. V, we don't actually know V. We know V up here, but we don't know it down here, so we can't use that at all. The acceleration is going down 9.8, so it's minus 9.8. And we also are given in the question that it takes 15 seconds to hit the C. So the time from A down to C is 15, so we can use that. Okay, so looking at the letters we've got, S, U, A, T, we can use S equals UT plus a half AT squared. Okay, so S equals 10 times 15 plus a half times minus 9.8 times 15 squared. And that comes out to be minus 952.5 metres. Okay, so let's think about what that actually means. It means that from the start to the finish, it travelled in the negative direction by this far. So from there, negative direction obviously is opposite this, so it's down. So it's travelled 952.5 metres down. So that distance there that's travelled down is the same as the height of the cliff. So we then need to write height equals, and of course we're going to give our height as positive, so 952.5 metres. Okay, part C is asking what is the maximum height of the ball above the sea. So if we look at our diagram, the highest the ball gets to is this point here. So we're probably going to want to know what the height is there compared to the original cliff, and then we could always add it on to the height of the cliff because of course our sea is just down here. Okay, so we're going to go from our starting point, A, and we'll go up to B, up here. So from A to B. So the distance, the displacement S is what we're trying to find. Okay, and we're going to go for up as positive for consistency. U we know is 10. V at the point B, which is where we're going to, so B is 0. The acceleration, because it's going down, is minus 9.8. And we did work out the time, but I suggest not using it just in case we made a mistake on that, so we won't use time. With our remaining letters then, S, U, V, A, that's going to give us this formula. So V squared equals U squared plus 2AS. Then we put all of our numbers in, so 0 squared is 10 squared plus 2 times minus 9.8 times S. Okay, bit of rearranging to do then and simplifying. So 0 squared is 0, 10 squared 100, and then 2 times minus 9.8 is minus 19.6 S. Okay, so I want to find out S, so I'm going to move this to the other side because I want it to be positive. So now I've got 19.6 S is 100. And then to find just the 1S, I'm going to divide by 19.6. That comes out as 5.10 metres. Okay, so remember that was from A to B, that's what we were working at there. So that's 5.10 metres, and then we want the maximum height of the ball above the sea. So the sea to the top of the cliff is 952.5, and then from the top of the cliff to the highest point is 5.1. So altogether, 952.5 plus 5.10 is 957.6. And as we're going for three significant figures, we're going to say that that's 958 metres to 3SF. final part of the question asks us for how long, so that's looking at time, the ball is at least 2 metres above the cliff top. So here's our cliff top. We want to be going 2 metres up from there. And we know from the first part that it goes up to about 5-ish or something. So there's about 2. So on my diagram, I'm going to draw a little dotted line and mark on that distance there as 2 metres, because that's what I'm looking for, 2 metres above my cliff top. So the time for which it's at least that high is everywhere from this point for that whole time there until it crosses there again. Okay, so what I could do is find the time after 0 where it crosses that point and it crosses that point, and then I can look for how much time happened between those two. So I'm going to look from the start of my cliff top. I'm going to get point B here, and I think that I'll actually also get point C at the same time. So if I start by looking from A to B, then I'm looking for a displacement from A to B of 2. U is still 10. I don't know the velocity at this height, I only know it right at the very top. So don't know it and I'm not trying to find it. Again, we're going to take positive as upwards. So acceleration is minus 9.8. And I'm looking for the time. Okay, so formula for that, S, U, A and T is going to be this one here. So we've got S equals UT plus a half AT squared. Putting our numbers in then, 2 equals 10T, and then a half times minus 9.8, it's going to be minus 4.9, and that's T squared. Okay, so this is why we did this practice on quadratics. We've now got a quadratic in T squared. So rearranging, I'm going to get 4.9 T squared minus 10T plus 2 is going to be equal to 0. I can then use my quadratic of T equals minus B plus or minus, and the rest of this formula, which remember you need to know off by heart. Substituting all this in gives us our two T values. Okay, so T equals 0.225, or our other option, if we use the positive root, is 1.816. You'll probably notice that I've given this to a little bit more than 3 significant figures. It's because I want to use my in-between answers to more significant figures so that when I round at the end, it's still accurate enough. Okay, so these are my 2 times. So we can sort of see on the diagram where those would represent. So this time is at 0.225 and 1.816 is all the way around here at C. So we're looking for how long it's at least 2 metres above the cliff top. We're looking for the difference between point B and point C. So if that's point B and that's point C, we can just subtract the difference. And that gives us our final answer of 1.59 seconds. So here's our first sort of what a wally mistake, just a big thing to watch out for so that you don't end up making this mistake yourself. Very similar question. You've got a ball projected up vertically with speed 10. So we've got speed 10 here, they've done that bit absolutely fine. They've got gravity on there of 9.8 acting downwards with a double arrow, that's all fine. And it hits the ground 7 seconds later. And they're asked to find how high is the cliff. My first thought might be they've got no SUVAT table here at all with the actual values, so that's definitely missing. But if we then look at their actual calculation, they've written the formula correctly. U, they're absolutely right, is 10. T is 7 because it told us that. And then they've substituted this all in fine. But because they haven't put on their positive direction or the table, they've made a mistake here. And they've got 9.8 for the acceleration, whereas actually we can see from the arrow here that it should be negative. So that needs to be a negative in there, and that will completely change the answer and will in fact give us a negative value here, which is what we're expecting for the change in displacement from here down to here. Okay, so watch out for making sure you've always got your positive direction written on. As a hot question to think about then, if we have a look at this where we've got a rain cloud in the UK, which is often around 2,500 feet above ground level, if you need the conversion, 1 foot is the same as 30 centimetres. And this asks, what speed is the rain travelling at when it hits your umbrella? So think about the fact that you've got gravity acting on your rain. Okay, so that's going to increase it. Perhaps try some vertical motion with this. I have a feeling you might be a little bit surprised by your answer. So think about then what other things might affect the rain that maybe we haven't considered so far. See you in the lesson.